All right, guys, so again, on Friday, there's a quiz. It revisits 2.2 and 2.3, third try at 1.5 transformations. But the last topic on there is what we're doing today. It is rational functions, but you don't have to actually graph them because you don't get to use a graphing calculator. All right, so we are going to start off by finishing the lesson from yesterday. For our warm-up today, we're going to do this awful problem at the bottom of worksheet 6B. So let me write 6B up here so you can, oh good. I'll pretend that was where I wanted it to be. The first thing you would normally do for one of these is look at the factors of which over which. The factors of 615 over the factors of 4. Now, I did look those all up, or figure those all out, I should say. I didn't look them up anywhere, but the factors of 615 were 1, 3, 5, 15, 41, 123, 205, and 615. And the factors down here of 4 were 1, 2, and 4. Okay, I can't read that. If this had come out with 2 nice ones, it wouldn't have mattered. But actually, we might want to talk about this a little bit. So I'll go ahead and write those down. So if you graph it, with a zoom 6, you get this. Doesn't appear very helpful. We could adjust the window, but I really want to know where at least one of the zeros is. Anybody think they can figure out one of them? I thought maybe -1 was one. Whoops, trace, -1, enter. But I got it's way up at 100 at -1. You guys tried -3, and that one did work, okay? Then you could find this other zero, or just real quick, can anybody figure out what would be close to -1 on this list? Like if I put 3 over 1, that wouldn't help, right? But 3 over 2, if I made it negative, that would be 1. 3 over 4, 5 over 2 wouldn't be 5 over 4. Those are all fairly close to -1. Anybody try those? One of those works. Yeah, -5/4 works. And then the one that we found that also worked was -3, right? Okay. So to find the other 2 and to find the irreducible factors, we need to do some division. Let's do the nice one first, and we can do synthetic division. -3, 4, -15, 43, 577, and 615. This concept is on section 2.4 when it's on a quiz next week, but it's not as complicated as this one is. All right, bring down the 4, multiply, and we get -12, add, and we get -27, multiply, we get +81, add, and we get 124, multiply, and we get, somebody help me, 372? Okay, 372, okay. Add, and we get 205, maybe? Times -3 is -615, so that did work out, okay. Bauer's brain was successful. Now, we have this -1.25, and you could do it as a decimal, okay? Wouldn't matter. I'm going to go ahead and use -5/4, but you could use -1.25. Bring down the 4, multiply, and you'll get -5. Add, and that's -32. multiply, and you get 40. Somebody check me. 40. Okay, then add and you get 164. And then it's negative 205. It does work. Okay. So we are supposed to write this as irreducible factors first for A. Can you tell me what the factor for negative 3 was? Okay. What is the factor for negative 5/4? We could write x plus 5/4. Okay. This down here represents what? This depressed polynomial. 4x squared minus 32x plus 164. What's the deal with all that? Why is it reducible or factorable? We can take a 4 out. I'm moving it out in front of everything here. If we take a 4 out of all that, we have an x squared minus 8x plus 41, I think, yes? Did anyone get that? Yeah. Okay. So this would be okay. The other option, that's a 41. That looks really funny. I don't know why. The other option would be you could have written, if you multiplied the 4 through this one, it would have come out as 4x plus 5. Would that still be negative 5/4? Okay, so either one of those are good for A. Now, before you try to do C or B, in my opinion, you should do C. Should find the zeros and then write the linear factors. Okay, it doesn't work at the bottom of the screen. Good to know. Okay, so we need all the zeros. We know there's a 0 at negative 3, there's a 0 at negative 5/4, but how are we going to find these zeros? Does that factor? It does say 41 right there. What do we have to do? Quadratic. Look at the graph. Is it going to be real numbers? It certainly doesn't look like it crosses more than twice, right? So I'm thinking we're going to get imaginary solutions. All right, so real quick, the opposite of B, plus or minus the square root of B squared minus 4 times 1 times 41, 4AC all over 2A, would be 8 plus or minus, anybody, I think it's negative 36, only because I did it this morning. We type in that, I think it's 64 minus, it's 48? Okay, it's 48, okay. Square root of negative 48? It definitely isn't positive, guys. 8, this is 64 minus 164, isn't it?
Yeah. So that would be negative 100.
Yeah. Is it negative 100? What are you typing? It's 41. This is a 41 back here. That's not a parenthesis, that's a 1. There we go. It's a 41, and this was supposed to be a 41 back here. Okay, now it's all over 2. So this becomes 8 plus or minus. What is the square root of negative 100? 10i divided by 2. They both have to divide by 2, so we get 4 plus 5i and 4 minus 5i. Whew, that was miserable. So that's actually the answers to C. Now D says we have, sorry, B, I skipped B. B says we have to write them as linear factors. Well, this one is x plus 3. Do you want to write this? Let's write this as x minus 5/4. Whoops. Yep, thank you. And then this one would be x minus, and I'm just going to leave the 4 plus 5i in parentheses. We could get rid of the inside one by distributing it, but I don't want to confuse you. Really? Okay, does anybody know why this answer is wrong? This is a, no, it wanted linear factors, so those are the linear factors, okay? The issue, guys, is that if I foiled all that back together, besides a huge migraine, I would get the wrong answer. Does anyone know why? It's a leading coefficient issue. What is the leading coefficient supposed to be at the beginning of this problem? A 4. Yes, we can either throw a 4 out in front, not an x, because that would make it degree 5. We can either throw the 4 out in front, or we could have written this one as 4x plus 5. Okay, I do hereby solemnly swear that I don't ask for one like that on a quiz, okay? I won't say there's not one where you have to have the leading coefficient at the end, because there is, but there's not one where the linear are, well, where they're imaginary like that, okay? All right, so your homework last night was to do these 9 questions. Please make sure you're working on those, because 2.4 is a section that I'm worried about on the next quiz. It's not on this quiz yet. All right, so today we're going to work on graphing rational functions. So rational functions mean that there's basically a polynomial on the top of another polynomial. Rational means can be written as a fraction. Okay, I'm going to be on worksheet 9A now. The things we have to be able to do are all the things on that little yellow reference sheet you picked up. We have to be able to find the zeros, the vertical asymptotes, the horizontal asymptote, or end behavior, any holes, what am I missing? Domain restrictions, all those things, okay? So we're going to get some crazy graphs today. By definition, a rational function simply means you have a quotient of 2 polynomial functions. So you got a mess on the top and a mess on the bottom. The domain, as always, is all real numbers except the ones that make the denominator 0. That's nothing new, right? So we've been doing domain restrictions on the denominator for quite a while. All right. The lines that this will approach, this is the most basic of all. This is just a reciprocal function. And we have done this. And we've done analysis of this, right? We talked about it was approaching x equals 0 out on the ends, and that it was getting closer and closer or hugging the y-axis here. Those are called asymptotes, and we have used that word. The end behavior of this particular one approaches 0 on the far left and far right, not infinity or negative infinity. Okay, it's very important that as you write that vertical and horizontal asymptotes, they must be equations. Notice this says vertical asymptote has equation x equals 0, and the horizontal asymptote has an equation y equals 0. You can't just write 0. It's got to be an equation because it's all the points along that line that are determining the asymptote. All right, I think this is off your notes. All right, it says for a function that has a as a polynomial on the top and b of x on the bottom, if there are no common factors other than 1, and the n is the degree of the numerator and m is the degree of the denominator, okay? So we have the degree of the top, the degree of the bottom, and that's going to determine our horizontal end behaviors. The vertical asymptotes will occur whenever you have zeros of the denominator, okay? So we set the denominator equal to 0, and we get vertical asymptotes will be x equals some number. Horizontal asymptotes occur if it is bottom heavy, in other words, the degree of the denominator is greater, then it approaches y equals 0. If they are what's called equal weight, then you have to take the leading coefficient and divide it. If the function is top heavy, in Algebra 2, even Honors Algebra 2, I believe, you just learned there was no horizontal asymptote. But in this class, you're going to have to find oblique asymptotes and what are called end behavior equations, because sometimes the asymptote is actually a parabola or something. And you're going to have to find the x and y intercepts. The x and y intercepts should make sense. The x-intercept is when the top equals 0, and the y-intercept is when you put in x equals 0, same as we've always done. All right, this horizontal asymptote business real quick. This one is bottom heavy because this is degree 1 over degree 2. Does everybody see that? The exponent power here is 1 and 2. So it's called bottom heavy because the numerator is less than the denominator. If I were to put 1,000 in here, I'd have 1,006 divided by what? A really big number, right? Because 1,000 squared. So no matter how big the top gets, the bottom is always getting bigger, which makes it all approach what? 0. So this approaches 0 as its horizontal asymptote because no matter how big you put a number in on top, when you square it, it's always going to be bigger on the bottom. All right, these two, if you put 1,000 in, you'd have really big numbers here, but they would divide out. What would be left? The leading coefficient. So this will approach y equals 2, and the rule is when the degree is the same, both of these are 2, you take the leading coefficient divided by the leading coefficient. Here, if the degree of the top is greater than the bottom, okay, it has no horizontal asymptote. But we're going to learn about an end behavior equation. We're going to learn we have to actually divide this. And this one we could use synthetic division to find the equation of the asymptote. I'm not going to do that one yet. All right, you will get a reference sheet, which you were given a copy of today, and you will get to use that on the quiz. It will not be the one you have. I will give you a fresh one the day of the quiz to borrow because I don't want you to write extra stuff on it. If you want to write extra stuff on your yellow one, go right ahead. Does that make sense? Because I'm going to give you a different one the day of the quiz, okay? Just so we're very clear, guys, down here at the bottom, when it is top heavy, you don't get to stop and just say there's no horizontal asymptote. You will have to follow down and do this, find it by dividing. All right. Here's my first example. It says find the domain for this function. So what do we do for the domain? It's all real numbers except what? Yes, the denominator cannot equal 0. So x cannot equal 3 is the domain restriction. And because there are so many parts to these questions, that's all you have to write. You don't have to write it in interval notation. Is everybody good? It says find the vertical or horizontal asymptotes. Okay, vertical asymptotes are found by setting the denominator equal to 0. So if I set the denominator 0, I get x equals 3. But you just told me x can't be 3. I need you to understand x equals 3 is a vertical asymptote that bounds the graph. It's not actually part of the graph. So, while x can't be 3, this is what it's going to approach. And so you have to state the equation of the vertical asymptote as an equation. It's not actually part of the graph of this function. We are going to graph it as a dotted line as a boundary. All right, the horizontal asymptote is when we look at the degree. What is this function, guys? Degree what over what? Degree 1 over 1, and when it is degree 1 over 1, we look for y equals leading coefficient over leading coefficient, which is what? Yeah, the leading coefficient is 1 out here in front and 1. So we get y equals 1 as the horizontal asymptote. Okay. Now, if you graph it on your calculator, I think I did this one. We'll have to check here. That's not the one we just did, is it? Okay. I'm just gonna let you look at the picture then. That's what it looks like. What's the important thing though? When you go type it in your calculator, what would you have to type? Very important. Parentheses, x plus 4 divided by parenthesis, x minus 3. Everybody good? You always have to have parentheses around the whole top and the whole bottom. All right, you have this example on your notes. Very similar to that one. The domain restriction, again, the denominator has x plus 3, so x cannot equal -3 is the domain restriction. The vertical asymptote is set the bottom equal to 0, so we get x equals -3 as the vertical asymptote, which is here. It is this vertical line that's dotted right there. It was equal degree again. So what is leading coefficient over leading coefficient this time? So we have y equals 2, okay? It also wants you to find the intercepts. How do I find the x-intercept, guys? How do I always find the x-intercept? Well, you put y equals 0. How are we going to make this whole thing equal 0? Look at your notes sheet, your reference sheet. What does it say about finding x-intercepts? How would you make this whole thing equal 0? The top has to equal 0, right? 0 divided by something would be 0. So we're going to set the top equal to 0. So 2x minus 1 equals 0 would be x equals 1/2. So if we put a 1/2 in, we'll get out a 0. Whoops, that's supposed to be a 0. So it's crossing over here to the right half a unit. Now they're counting by 2s, so you can't even tell, but that's that blue over there. The y-intercept, how do you find the y-intercept, guys? Always, no, that's, for x-intercept, you set the y to 0. For y-intercept, you set x equals 0. So if you put in a 0, 2 times 0 minus 1 over 0 plus 3, you'll get -1 over 3. So it is crossing the y down here at -1/3, okay? Very hard to tell on that graph. And it, again, it would be 0, comma, -1/3 if you wrote it as an ordered pair. If I graph it, I have it here. I have 2x plus 1 in parentheses divided by x plus 3. If I do a zoom 6, that's actually a pretty good window, right? I can see things. Did I write that down wrong? It doesn't cross the x at 1/2 though, does it? Oh, do I have it typed in wrong? It's 2x minus 1. Did I type plus 1? Yes, okay. I was like, something's wrong. Okay, if I type it in correctly, that looks better, okay? It is crossing over here at 1/2 and down here at -1/3. Everybody good? All right, we are gonna try this one. It is x plus 2 over the quantity x times x minus 6. The first thing you always have to do with the denominator is factor it if necessary. Well, both numerator and denominator. This one is in factored form, which is kind of weird. But the domain restriction first, anybody? What are the two things that would make the denominator 0? X cannot equal 0 or 6. So there are two vertical asymptotes. They occur at x equals 0 and at x equals 6. Now x equals 0 is the y-axis, so there's one of them. This paper is counting by 2's, so x equals 6 is over here. Okay. Where are the intercepts of this? The x-intercept is when the top is 0, so that would be at what? -2, 0, which would be right here. The y-intercept is what we get when we put in a 0. Can we put in a 0, guys? If I put in a 0, I get -2 over 0 times -6. Isn't that undefined because you get a 0 down there? So it has no y-intercept, which is why it had a vertical asymptote there. All right, we're going to try to graph it. We do have to put the entire bottom in parentheses. So we're going to type y equals x plus 2 in parentheses divided by the quantity x times x minus 6 with an extra parenthesis, or you could distribute, and then you wouldn't need the extra parenthesis, but I wouldn't bother. Okay. Do I have it right this time, guys? X plus 2 divided by x times x minus 6. Okay. If I do a zoom 6, what's somebody gonna think when they see this graph? Well, I hope they don't think that. We did know that there was going to be two vertical asymptotes, right? But this is very misleading, in my opinion. If I were to turn, don't mess with this on yours, but if I were to turn the axes off, can I make them just off? Well, I could make them white, I guess. That was weird. Look what happens. Is this right? Does this graph actually end at certain places? It doesn't. It's right. Let me quick turn my axes back on. Where they were just black, weren't they? Oh, there was off. There was an off. Okay. Yeah, good question. Okay, what I wanted to try with you guys real quick, if you go to the graph, you could do a zoom decimal, you could try some different things. I very rarely use the first thing under zoom. If everybody goes to zoom, the first one is box. Okay, I want to try that one with you. Pick zoom box. And then what you have to do is scroll to the upper left corner of where you think you want to draw a box. So I went about here. And then I hit enter. And then you have to scroll down and to the right to draw the box. And so I went, this is the area I really want to see right here. So then I hit enter. Now this clearly doesn't look like it's ending, right? So it's kind of a click and drag box. Do you get what's happening, guys? You guys are much more tech savvy than I am. But I thought that was a good feature for that particular graph to use. All right, what did we get for an x-intercept and a y-intercept? -2, so we could do a quick trace, -2 if we wanted. And it should come up 0. And for y, we didn't get one, right? It does look like it eventually touches here, but if you were to trace this way closer and closer, it'll just jump over to the other branch. Okay.
Wait, what about 0?
What? If you put in 0, it's undefined. This is an important issue. When you graph, if there are multiple vertical asymptotes, on either side of a vertical asymptote, there should be a piece of the graph. So this one had something over here. It had something down here. How far down was that? Could we tell? Not very far, right? This, yeah, it's not even down to -1, so it's very close in here. And then it was back over here again. Okay, here's my question. What is bothering you about this graph? It's bothering me that this crossed. Okay, the y-intercept, or I'm sorry, the horizontal asymptote. Does this have one? What is the degree of the top and the degree of the bottom? Okay, degree 1 over degree 2, because it had an x squared if we multiplied it together, makes it bottom heavy. What does bottom heavy mean? Yes, so y equals 0. So the horizontal asymptote is here. But it crossed that. We had an x-intercept. Is that okay? Yes. The answer is yes. It can cross a horizontal asymptote, but it can never cross a vertical asymptote.
Excuse the interruption.
Yes.
Could you send Destiny Byers to the counseling office?
Yes.
Thank you.
It will never cross a vertical asymptote, but it can cross a horizontal asymptote. It simply means at the horizontal asymptote is called end behavior because it means out at the far ends, okay, it's going to approach that value. I'll show you where that is on a reference sheet in a minute. All right, everybody good with that one? This is a really weird one I just wanted to cover real fast. Guys, 4x squared plus 1, can that ever equal 0? Not with real numbers, right? Well, think about it. 4x squared equals -1. Divide and square root, you get imaginary numbers. Same thing with the top. 8x squared plus 5 equals 0. You'd get imaginary numbers. So it has no x or y intercepts or vertical asymptotes. Is it top heavy, bottom heavy, or equal weight? Okay, because it's equal weight, we need leading coefficient over leading coefficient, which would be what? 8 over 4. So the horizontal asymptote is at y equals 2. If you graph it, it actually looks like this. And you know what? I think I just said that it doesn't cross x or y, but I was wrong. It crosses y because you can put in x equals 0, right? If you put in a 0 here and here, what will you get? Well, 8 times 0 plus 5 is, and 4 times 0 plus 1 is 1, right? So it does cross at 0, 5. So you get a really weird graph for this one. It has an intercept up here at 5, and other than that, on both sides, it's getting closer to y equals 2. Okay. All right. Do you have these? Okay. Real quick, what's the domain restriction on this one? Can you see, guys, what's the denominator down here?
5.
Oh, we should factor the top, I think. What comes out of the top?
5x.
Okay, So the domain restriction is x cannot equal -1. The vertical asymptote would be at x equals -1.
That's a 5. Yeah.
Oh, thank you. Someone fix me. This is a 5. So this is a -5, and this is a -5. Okay. Horizontal asymptote, equal weight, yes? So the horizontal asymptote would be at y equals 15. Okay, this is the kind of thing that's on the quiz where you don't even have to be able to graph it, okay? I'm not going to ask you what the graph looks like. I'm just going to say identify where those things are. This one, the top factor is how? X. Okay. So domain restriction, anybody? X cannot equal -4. Everybody good? Where are the zeros or the x-intercepts? It's when you set the top equal to 0. 3, 0, and -2, 0. Okay? Where's the vertical asymptote? X equals -4, because that's what makes the denominator 0. All right, this one is top heavy. Top heavy means we have to actually divide to find the oblique asymptote, which means, could we do synthetic on this one? So we would have -4, and then we'd have 1, -1, and -6. Bring down the 1, multiply, add, multiply. Good news. You get to throw away the remainder. So y equals x minus 5 is the oblique asymptote. Do you see how that could work there? Okay, we're not going to talk too much more about oblique asymptotes today. I want to get to the holes, okay? So your notes, I think, have these steps for you. Will you write by step 4, just use your calculator? Do you have these on your notes or no? Okay, just kidding. You have instead your reference sheet, okay? All right, do you have these? Okay, so let's see if we can get through these real quick because I want to talk about holes still. Find the domain of each function. Can the denominator here, x squared plus 1 equals 0, gives me x squared equals -1. If I square root that, I get imaginary. Is there anything that's going to make that denominator 0? No, so this one has just all real numbers. I'm just going to write that because I'm too lazy to write. That's an R. I'm too lazy to write -infinity to infinity. Second thing it wants is vertical asymptotes. If the denominator can never equal 0, does it have any vertical asymptotes? Okay, top heavy, bottom heavy, equal weights. So for the horizontal, it's bottom heavy, so it's what? Is that all they asked for? Yours doesn't say graph, does it? Okay, so let's move on to number 2. Domain restriction? X cannot equal -1, but there is a vertical asymptote at x equals -1. Top heavy, bottom heavy, equal weights. So horizontal asymptote, it is equal weight, so it's y equals leading coefficient over leading coefficient, which would be 2. All right, last one, domain restrictions. -1 or +2, which means there are vertical asymptotes at -1 and x equals 2. Okay, top heavy, bottom heavy, equal weight. Bottom heavy means y equals 0. Okay, could you do those kind of things on the quiz? Well, you have the reference sheet, right? Okay. I want to talk about a hole. We'll come back to oblique asymptotes tomorrow. There is a hole in a graph if you have a common factor top and bottom. For example, this question factors x plus 2, x minus 2, and the denominator factors x minus 4, x plus 2. The hole exists because there's a common factor top and bottom. You're going to cross that out, but before you do, you have to find the domain restriction, x cannot equal 4 or negative 2, and you're going to say there's a hole when x equals what? The one you're going to cross out, negative 2. Okay, but you have to find the ordered pair for the hole. So when the negative 2 goes in, guys, look at the directions here. I love this. What it says on 8.5, it says, to find the hole, set the canceled factor equal to 0 and solve for x. And then plug back into the beautifully new simplified equation, that value. The beautifully simplified equation means when you plug the negative 2 in, you have to plug it in after you've divided out the common factor. If you plugged it into the original, you'd get 0 over 0. Okay? But if you plug it into this new one, which was x minus 2 over x minus 4, if you plug a negative 2 in there, you get negative 4 over negative 6. So the hole exists at negative 2 2/3. Do you have a question about a hole on your sheet?
2 and 5 are below.
Oh. This one has a hole? Okay, this is a nightmare. Let's see how far we can get on this problem. The reason I say it's a nightmare, because we have to factor first. I don't know how to factor that denominator, do you? You actually kind of do, because we just did things like that. How do we find the zeros for this? We graph the denominator only, okay? If we graph the denominator only, it has zeros at negative 3, negative 1, and 2. So now do we know how to factor it? How would the denominator factor? If I graphed the denominator only and I got a 0 at negative 3, then what's a factor? Okay, I got a 0 at negative 1, so it has a factor of x plus 1. I got a 0 at 2, so it has a factor of... Okay, what about the top? X minus 7 and x plus 3. Does this have a hole? Okay, the only thing you have to do before a hole is you have to do the domain restrictions. Guys, where's the domain restrictions? X cannot equal negative 3, negative 1, and positive 2. Then do the hole. The hole exists. We get to cross out this factor. Where was the hole at? Negative 3. And then how do you find the rest of the ordered pair for the hole? You plug negative 3 back in here. So we get negative 3 minus 7 over negative 3 plus 1 times negative 3 minus 2. Lovely. I'm getting negative 10 over negative 5 times negative 2, positive 10, anybody? Right? Okay, so we get negative 1. So at negative 3, negative 1, there is a nice big hole in my graph. There are vertical asymptotes where? What's left in the denominator? X equals negative 1. And what x equals 2. Okay, then I can plug it in my calculator very carefully. This is what the graph looks like. So it is down here. Does it ever cross? Where does it cross? The x out here at 7. but it doesn't cross over here.
Is there anything over there?
And then up at the top, the y-intercept is at 21.6, which would be 7/3, a little between 2 and 3. So the x-intercept was at 7.0, and the y-intercept was 0. What's 21/6 reduced to? 7/2. Okay, so my little whoop-de-whoop isn't up far enough. Should be up there. All right, so I didn't get very far either, Abruzzo. So here's what they're supposed to be working on that no one will work on, so.